Okay, so moving forward in the chapter, and I know you guys will be very much tired, bored of studying the same things again and again, but this is how it is. You're going to study the same sort of template things, the physical properties, and the homologous series, and the formulas, naming for all of the molecules. And that's just the ground reality. But also telling you that organic is the most interesting of all of the chemistry. It's very, very fun, especially the reactions. Okay, so yeah, moving forward to the physical properties of alcohols, and it's going to be a pretty short video because there isn't a lot in this one. So yeah, there are only two things that you guys need to keep in mind in terms of physical properties of alcohols. The one thing is solubility, and the other thing is the melting point and the boiling point. Okay, so if I talk about solubility, so solubility, as I go down the series, it's going to decrease. Okay, so as I go from methanol to ethanol to propanol to butanol to pentanol, the solubility is going to decrease. And as for the melting and the boiling point, as I go down the series, the melting point and the boiling point are going to increase. Right? These are just the two things that you need to keep in mind with the physical properties of alcohols. So let me just draw a quick table. So you've got ethanol, you've got methanol, you've got propanol, you've got butanol, and yeah, that's enough. So I can just quickly write solubility. So this is the name. Then you've got, and let me just change the color. This has got solubility. Then you've got the physical state, and then I've got the boiling point. So I'll just write the boiling point. Okay, so for methanol, now methanol is, and this is we're talking about solubility in water. Okay, talking about solubility in water. Now methanol is very soluble. Right? And remember the series, remember the trend. We say that as we go down the series, the solubility is going to decrease. So in methanol, it is very soluble. In ethanol, it is again very soluble. But now, since we're going down the series, when we talk about propanol, it's going to become soluble. And when we talk about butanol, we say that it is slightly soluble. Okay, so this proves your trend, right? That as we go down the series, the solubility is going to decrease. And if I talk about the boiling point first, let's talk about the boiling point first. So methanol has a boiling point of 65 degrees. Ethanol has a boiling point of 78 degrees. Propanol has a boiling point of 97 degrees, and butanol has a boiling point of 118 degrees. See, the trend as we go down the series, the boiling point is increasing, and this goes the same for the melting point. I'm not writing the melting point temperatures because temperature is not something that you need to learn. You need to learn. The only thing that you need to learn about is that the trend, and the trend is that as you go down the series, the melting point and the boiling point are going to increase. Okay. Now, physical states at methanol at room temperature. Now, this is we're talking about at room temperature. Okay. So at room temperature, the physical state of methanol is going to be liquid. Ethanol is also going to be liquid. Methanol is also going to be liquid. Propanol is also going to be liquid, and butanol is also going to be liquid. Right? All of these molecules are going to be liquid at room temperature. And the last thing about this is that the short chain alcohol molecules, I missed that one again. So the short chain alcohol molecules, which are basically these ones as well, because till C3, C4 we call it short chain molecules. Okay, so I think C2 till here you can say best about the short chain molecules. So if we talk about the short chain molecules of alcohols, these are very volatile liquids, right? Why? And what word volatile means is that they have a very high tendency of being evaporated. Like they have low boiling points. Here I know I said that they have a general rising trend in the boiling point, but if I compare it to, you can say, but generally the boiling point is still low. Okay, these are very high boiling points. Like if you compare these boiling points with water has a boiling point of 100 degrees centigrade. right? And all of these molecules, like till here, you can say till propanol, this is under 100 degrees, meaning that the boiling point of these three alcohols is less than water's. Okay, so you can compare it with water and say that this is slightly lower boiling points, right? But the trend is that as you go down the series, the boiling points of alcohol molecules are going to increase. Now, what I was trying to explain to you guys was these are volatile liquids, meaning that you might have heard about petrol or you might have heard about some other molecule that we talk about, and we say that you shouldn't leave these things in open because they will evaporate. So that's what being volatile means. So if I keep it open, and because it doesn't have a very high melting point, sorry, a very high boiling point, it's gonna evaporate. Okay, it's gonna evaporate, and that's not what we want, right? So that's the idea, and yeah, that's mostly it. And if you compare these boiling points with the boiling points of alkenes, which are the hydrocarbons, these are generally higher melting points. Yeah, because if you remember, the melting points or the boiling points of the alkenes and alkenes were basically in minus degrees. Okay, so this is all about the physical properties of alcohols. Right? Bye.